In the world of statistics, it's not enough just to talk about the average of a set of data. We need more than that. You can talk about center or average. This average is about the same as that average, but this data is much more spread out than this. So it takes more than just measures of center, which are averages. We need measures of center and we need measures of spread. So we can say about these two distributions that they have similar spread, but this center is lower than that one. And this one have similar centers, but this is less spread out than that distribution there. So measures of center are averages. The mean average, the median, the mode, most of us are familiar with those. Median, the score in the middle, or the scores in the middle. Mode is the one that occurs most often. And you can have more than one mode. You call it multimodal. The mean average, add them up and divide by however many scores we have. Now, this is the way we define the mean average. It's x bar, and it equals the summation of x divided by n. So all that's saying is add up all the scores and divide by however many you have. We just make things look more complicated in the world of statistics so that we can feel better about ourselves. All right, now suppose we took a sample of secretaries in a certain industry and we found their incomes in thousands, and these are the incomes right here. Well, then this is how we find the mean, add them all up and divide by 10. We get a mean of 34.4, which would be $34,400 a year. Then to find the median, it's the score in the middle after we've arranged everything. And because there's an even number of scores, there's actually two scores in the middle. If we put a segment down the middle of those two, there's 5 scores below and 5 above, so that's the balanced point right there. So if we add these two up and divide by 2, that gives us a median of 34. Now if there were an odd number of scores, we'd only take the score that's in the middle as our median. Whoa, is there a bug on your shoulder? Clearly you can see now there's only 9 scores. There's no longer an even number of scores, there's only 9. So now if we were to find the median, we'd say, well, by golly, it's the score in the middle. And the score in the middle would be the 32, because there's 4 below and there are 4 above. So with an odd number of scores, there's only 1 score in the middle that's the median. The mode is the one that occurs the most often. Well, by golly, we have 2 modes. 30 occurs twice, and $42,000 incomes occur twice also. So there'd be 2 modes. Now we need the measures of spread. We have range, which is to take the high minus the low. The interquartile range, which is the difference of the third quartile and the first quartile. A new one, some of us have seen this before, others haven't, but standard deviation, and that ugly looking formula right there. And then the variance, which is simply the standard deviation squared. And to be honest, we actually find variance first and then take the square root of it, the radical of it, but we'll get to that later. But these are our measures of spread. Now let's look into those a little bit. There's our data set, the range, the high minus the low. We have a range of 20,000 in our data set. The nerd tells us the range can be misleading. It's a weak statistic because it only looks at 2 scores. You can have 1,000 scores in your data set. It would ignore 998 of them and only look at the max minus the min. So you can see if we had our set of data and then we have another set of data where there's an outlier but most of the scores are up here, that range is 20,000 and this range is 20,000. Well, that can be really misleading. These are more spread out, these are more concise, less spread, but just with an outlier. So the range in and of itself is not a statistic that we like to use that often. The interquartile range, Q3 minus Q1. So remember, we have an even number of scores, so the median is right there, splitting the data into 2 halves. The lower half, there's 5 scores. So the first quartile, being at the 25th percentile, is halfway through the lower half of scores. So this would be our first quartile. The upper quartile, the third quartile, is in the middle of the upper half of scores. It's at the 75th percentile, at least approximately. So that would be this score right here. That would be the third quartile. So if we take Q3 minus Q1, that's a difference of 12 or $12,000. So that would be our interquartile range. And remember, it's where we find approximately 50%, the middle 50% of our data. So the interquartile range is a very good statistic. And even though you may think it only looks at 2 scores, like the range, the high minus the low, not true. because it considers where all the other scores are positioned by saying, oh, let's find the score that's at the 75th percentile and approximately at the 25th percentile. So it's a legit statistic, it's a good one. Then we need to get to the standard deviation. Now first, let's talk about deviations. Deviations of scores, in the world of statistics, X is each individual little score, X bar is the mean of all the scores in our sample. So what we do is we take each score minus the mean, and that difference is a deviation. So if we look at this $24,000 salary compared to the mean of $34,400, 34.4, if we take this score, this X, minus that mean, we get a deviation of negative 10.4, negative $10.4 thousand. So you'll see that all these scores that are below the mean have negative deviations. All the scores above the mean have positive deviations. Now this score is about 1.6 units above the mean. This score is 3.6 units above the mean. So positive deviations, negative deviations. Now the sum of all the negative deviations is negative 30. The sum of all the positives are positive 30. Well, that leads to a problem. Suppose we say, hey, let's find the mean average deviation, the mean average difference between a score and the mean. Well, the problem with that is all these negative deviations add up to negative 30, those 5 scores. The 5 positive deviations add up to positive 30. So when you add them up, you get 0, which makes sense. On average, the average score is right in the middle where the mean average is, so the average deviation is 0. So that's not good enough to take the mean average deviation. That's kind of a waste of time. So then we could look at something called the mean absolute deviation. I believe this is what Common Core started using this past year. We'll take a look. But at any rate, what we do is we just take the absolute value of each deviation. So we could call it the distance of every score away from the mean. So even though this score is 10.4 units below the mean, so the absolute value of negative 10.4 is 10.4. So these absolute values of the deviations are how far each score is away from the mean. Now that gives us something more meaningful. When we add up all these absolute values of the deviations, we get a mean average of 6. So what's the interpretation? Well, that would be that on average each score is about 6 units away from the mean in one direction or the other. So that helps us out. So the bigger the mean absolute deviation, then the more spread out the scores are. Well, but that takes us up to an even more powerful statistic, S, the standard deviation, and its parameter, sigma, the lowercase Greek letter. Look, there's sigma. Okay, so we need to get to the standard deviation. Now here's how we find it. Instead of taking the absolute value of every deviation to get rid of the negatives and be able to add them up, we instead take the square of all the deviations to get rid of the negatives, but once we've squared everything, they're so much bigger. So what we do to get back down to the level of the numbers we're working with is to take the square root, or the radical, I prefer to call it radical sign, the radical of the sum of all the squares divided by the sample size minus 1. So again, we take this guy, this negative 10.4, that deviation, we square it. We add it to the next score's deviation squared, and the next score's deviation squared. And we keep doing that up through all the data points. We add up all the squares of the deviations. We divide it by 1 less than the sample size, and we're going to talk about why that is in another video. And then we take the radical of all those things. So what we get is a standard deviation of about 7.04. Now, what's the interpretation? Really, we should say, you know what, it's kind of on average how far is every score away from the mean. Now, the actual distance, you recall, was 6. If we truly took the mean absolute deviation, it's 6. So every score, on average, is 6 units away from the mean. The standard deviation, the layman's interpretation of that is about the same. It's roughly the average distance of each score from the mean. It's a good enough thing to wrap our brains around and go with that. Now the question would be, what's so much more powerful about this than the mean absolute deviation? And the answer is, when we get to the normal distribution, which is the heart and soul of statistics, this statistic and its corresponding parameter, we'll deal with parameters later, are extremely important. The characteristics of this guy are really impressive, and they allow us to do some serious analysis. So you'll find out later why this is so much more powerful. Just be comfortable being able to follow the formula and get your standard deviation that way. And then the variance would be really what happens just before we take the radical of everything. It's after you've squared all the deviations and added them up and divided by one less than the sample size, that number you get, which would have been 49.60, that's your variance. Once you get that, you take the radical of it, and that takes you back to the standard deviation. So the variance is just the square of the standard deviation. The standard deviation is just the square root of the radical of the variance. So if we say, hey, we looked at incomes in thousands of secretaries in our sample, the incomes of the secretaries in our sample, and these were the measures of center we got. We got the mean, the median, and the mode, and these were the measures of spread, the range, the interquartile range, the standard deviation, and the variance. Those are the measures of center and spread. We will learn later when it's appropriate to use which measures of center and spread in combination to describe a distribution. The last thing I would say is on your calculator, you can go into the calculator and do 1var stats to find these variables, and we will deal with that later in another video as well. But that's an introduction to center and spread.